Hello guys, myself Pratul Datto. Today I am going to present you a cardiovascular risk prediction project for AlmaBetter. This project is done as a solo project. Here is the project summary. The goal of this project was to use the machine learning techniques to predict the 10-year risk of future coronary heart disease in patients using data from an ongoing cardiovascular study on residents of town of Birmingham. The dataset provided information over 4,000 patients and include 15 attributes, each representing a potential risk factor for coronary heart disease. These attributes included a demographic, behavioral, and medical risk factors. To prepare the data for analysis, extensive processing was performed to clean and transform the data. This included handling missing values using median mode as well as identifying and removing outliers using the interquartile range method. Skewed continuous variables are also transformed using log and square root transformations to reduce the skewness and improve model performance features. Here is the GitHub link for my project. Here is the problem statement. Problem statement for this project is to develop a machine learning model that can accurately predict an individual's risk of developing coronary heart disease by incorporating a wide range of variables, including demographic, clinical, and lifestyle factors. The model should be interpretable, reliable, and able to provide personalized risk predictions that can aid in development of prevention strategies for high-risk individuals. Here is the general guidelines for the project. So let's begin the project. So first of all, we need to import some libraries like NumPy, Pandas, Seaborn, Matplotlib, and some machine learning model. So next is the dataset loading. So for analyzing the data, we need to include the dataset in our project. So for this, first of all, mount the Google Drive and then copy the path of the dataset in the drive and then create a copy of the dataset. Here is the first view of the dataset. So this dataset has 3,390 rows and 17 columns. Here is the information of the dataset. So here is the total 17 columns and their values and their data type. So this dataset has 0 duplicate values, but this dataset has some missing values and null values. Like education column has 87 missing values, while the cigarettes per day column has 22 missing values, and so on and so forth. So here is the graphical representation of the missing values. So from here we can clearly say that the glucose column has the most missing values among the all columns. So total number of missing values are 510 and there are no duplicate values found. So let's understand the variables. Here is the all column names of the dataset and here is the description of the dataset. Like ID column has 3,390 rows and the mean of these values for the column is 1,694.5. So here is the description for the all columns. Here is the variables description. Like the ID column means it represents an identifier or unique identifier for each individual in the dataset. Age represents the age of individual in years. Education represents at the level of the individual, which could be encoded categorically. And sex, it indicates the biological sex of individual, which is male or female. Smoking column indicates whether the individual is currently smoking or not. Cigarettes per day represent the number of cigarettes smoked per day by any individual. Prevental stroke, it indicates whether the individual has a history of stroke, typically encoded as binary value. Diabetes indicates whether the individual has diabetes. BMI indicates that the body mass index of the individual. Heart rate indicates that the heart rate of individuals beats per minute. Glucose represents the blood glucose level of the individuals in milligram per deciliter. While the 10-year CHD, this column indicates that the presence or absence of the 10-year risk of developing coronary heart disease for the individual. So let's check the unique values for each variable. ID column has 3390 unique rows, age has 39 unique value, education has 4 unique value, sex column has 2 unique values, and so on and so forth. So let's start the data manipulation. So first identify that the missing value percentage of column wise. So glucose column has 8.97% missing value, education has 2.57%, BP mates has 1.3%, cholesterol has 1.12%, cigarettes per day had 0.6%, BMI has 0.41%, and heart rate has 0.03%. Visualizing the data distribution of the numerical columns which have missing values. And let's fill in the numerical missing values with the mean value. So the BMI column has filled with the mean of that column, and glucose column has also filled with the mean of the column. Cigarettes per day has filled with the mean of the column. So let's find that there is any null value left. So there is also education has 87 null values, but BP mates has 44 null values. And also education column has filled with missing values, and the BP mates column has also filled for their missing values. So let's identify that there is any missing value left. So from this we can see that there are no missing values left. So let's divide the numerical data and the categorical data. Here is the total column. So to identify the categorical variable, we separate it from the total column, and also we can separate that numerical column. So here we have separated 2 categorical variables and 14 numerical variables, and dropping the ID column because it has no use for prediction of the 10-year coronary heart disease. Numerical variables are like age, education, cigarettes per day, BP mates, prevent stroke, prevalent hypertension, diabetes, thought cholesterol, BMI, heart rate, glucose, etc. And let's identify that there is any discrete variables left. So from the analysis we can see that there is a total 8 discrete variables, which is education values has 2, 4, 1, 3, sex values have male or female, is smoking values yes or no, BP mates values 0 and 1, etc. Continuous, in case of continuous features, so there is a total 8 continuous features. So let's start the data visualization, storytelling, and experimenting with charts to understand the relation between variables. So first analysis the dependent variables. So from here we can see that there is a 15.1% of value 1 and 94.9% are value 0. So it is a imbalanced data set. Next is the effect of education on risk analysis. So from here we can see that the highly educated persons have the risk of lower. Highly educated person has the lower risk for getting a coronary heart disease. Analyzing the risk on the gender basis. So from here we can see that there is a chances of 10-year coronary heart disease for the male is slightly more than the female. Next is the effect of smoking. So the male candidate who have smoking, then there is a chances more for getting a heart disease than the female. Next is the effect of blood pressure medicines. So the male patients who have taken the blood pressure medicines have the higher risk for a heart disease than the female candidates. Next is the effect of prevalent stroke. So from the graph we can easily understand that the patients having prevalent stroke are more prone to coronary heart disease risk. Next is the effect of diabetes. From the graph you can easily understand that diabetes patients have more prone to coronary heart disease risk. Effect of prevalent hypertension. The people who have a hypertension are more prone to coronary heart disease risk. So from the graph here we can see that the continuous data distribution. Age is positively skewed data. Cigarettes per day are almost positively skewed data. And next is the systematic blood pressure is the positively skewed. Diabetes blood pressure is positively skewed. Body mass index are more positively skewed, and the heart rate are almost positively skewed, and glucose is highly positively skewed data. So most of the data are skewed, so need to transform the data. Effect of body mass index and gender. So most of the female candidates have between 25 to 30. Most of the female candidates body mass index in between 25 to 30. And next is the smoking and gender. So the most of the females are non-smoker, while some males are smoking 20 per day, 20 cigarettes per day. Systolic blood pressure and gender. So from here we can see that the female has the blood pressure in between 100 to 150. Diabetes and glucose. So from the graph here we can understand that the people who have higher glucose level are more prone to diabetes, and the people who has a lower glucose level are also prone to diabetes. So here is the correlation heat map. So from this graph we can easily understand that the systolic blood pressure and the diastolic blood pressure are the highly correlated, and the systolic blood pressure and the prevalent hypertension are also correlated, and the diastolic blood pressure and the prevalent hypertension have high correlation. So here is the pair plot. Here is a pair plot of different variables with different variables. So here you can also see that the systolic blood pressure and the diastolic blood pressure have high correlation. Here is a pair plot among the different variables of the data set. So next is the hypothesis testing. Here is the first hypothetical statement. Null hypothesis that there is a no statistically significant relationship between the 15 attributes and the 10-year risk of CST, while the alternative hypothesis tells that there is a statistically significant relationship between at least one of the 15 attributes and the 10-year risk of coronary heart disease. So let's perform a statistical test. So here is the statistical test, and here is the p-value. So we use the ordinary least squares function from the stats model package. In this case the p-value is 0.0006, is less than the significant level of 0.05. So we can reject the null hypothesis that there is no relationship between prevalent stroke and 10-year coronary heart disease. Therefore, based on the available data, there is evidence to support the alternative hypothesis that there is a relationship between smoking and 10-year coronary heart disease. So the ordinary least squares regression model is commonly used to assess the relationship between a dependent variable and one or more independent variable. So, so next is the feature engineering and data preprocessing. So let's check the outliers and handling the outliers. So from the graph we can easily understand that the H column has no outliers and the cigarettes per day had 2 outliers and the total cholesterol had also 2 outliers, while systolic blood pressure has one or more outliers. Diabetic blood pressure has outliers. Body mass index has 2 outliers. Heart rate has outliers. Glucose level has more outliers. So there is a more outliers in the data. For handling outliers, I used outlier capping with percentile. So after applying the percentile, we can see that there is a massive difference between the outliers of the dataset. Here we can see that there are no outliers present in the dataset. Heart rate, but in case of glucose column there is some outliers left, so we cannot do too much into that, so left as it is. So next is the categorical encoding. So for categorical encoding I used label encoder for the sex column and the is smoking column. Now let's calculate the variance inflation factor. Here is a function which can calculate the variance inflation factor and return a table. So in the table we can see that the systolic BP, those columns as it has high VIF value. So after eliminating it, I will assign it as a independent variable and the 10-year coronary heart disease column as the dependent variable. So in case of independent variable we can see that the chosen independent variable has a lower VIF value. So as the data is highly skewed, we need to transform the data, and I use the log transformation. So here is the difference between the before log transformation and after the log transformation. So now visualize the data after the transformation. It is the data after the log transformation. So for building the machine learning model, we need to split the dataset into the train and the test dataset. And next is to scaling the dataset. For scaling, I use the min-max scaler, and for handling the imbalanced dataset, I use the synthetic minority oversampling technique for handling the imbalanced dataset. So next is the machine learning model implementation. So for machine learning model implementation, first I create a function to analyze the model and its efficiency and accuracy. First is the logistic regression model. So for logistic regression, I create a grid for the cross validation and hyperparameter tuning. So first let's build the logistic regression model and fit the train dataset and then analyze the model. In case of logistic regression, we can see that for train training dataset, we have the recall value of 0.7 for 1, F1 score value around 0.68, and the precision is 0.67. While for the test dataset, the recall value is 0.67, but the precision is 0.25 and the accuracy is 0.66 and the AUC score is 0.737. Next machine learning model is support vector classifier, and here we also create a grid for hyperparameter tuning and build the support vector classifier model and fit the trained dataset into that. And in case of support vector classifier machine learning model, we see that the recall value for the 1 is 0.73 while the accuracy is 0.67, and in case of 0, the recall value is 0.61 and the F1 score is 0.65. And for the test dataset, the recall value is 0.67 and the accuracy is 0.63, but the precision is 0.23 and the AUC score is 0.66. Next model is NAPIS classifier. So for this model, the recall value is 0.21 and F1 score is 0.33, which is very low. And for the test dataset, the recall value is also very less, around 0.3, 0.23, and F1 score is 0.29. And the AUC score is 0.728. Next is XGBoost classifier. Here we create a grid and fit the trained dataset. Here we can see that the recall value for the 1 is 0.87. In case of trained dataset, F1 score is 0.86. While the test dataset, the recall value is 0.42, F1 score is 0.31, and the AUC score is 0.65. And the most important feature for this machine learning model is prevalent stroke as the highest priority for this model. Next is the neural network classifier. Here we also create a grid and fit the trained dataset into that. And after analyzing the model, we have some reports like the in case of trained dataset, the recall value is 0.71 and the F1 score is 0.71. And in case of test dataset, the recall value is 0.56, F1 score is 0.34 and the accuracy is 0.68 and the AUC score is 0.675. Let's create a table for the accuracy, recall and F1 score and the precision of the all machine learning models. So from here we can see that the accuracy of the Gaussian NV has the highest accuracy. So from that we can easily understand that the performance of the among evaluating the performance of the several machine learning models on the Birmingham Heart Study dataset, I have selected the logistic regression as our final prediction model. The decision was based on the model's performance on primary evaluation metric of recall, which measures the ability of the model to correctly identify patients with CST risk. In our analysis, we found that the logistic regression and the support vector classifier had the highest recall score among the models we evaluated. We choose recall as our primary evaluation metric because correctly identifying patients with CST risk is critical to achieving our business objectives. By selecting a model with a high recall score, we aim to ensure that we correctly identify as many patients with the risk as possible, even if it means that we may have some false positives Overall, we believe that the logistic regression is the best choice for our needs and will help us to achieve a positive business impact. So, in conclusion, this project demonstrates the potential of machine learning techniques to accurately predict the 10-year risk of future coronary heart disease in patients using data from an ongoing cardiovascular study. Key points from the project include careful data pre-processing and transforming improved the performance of machine learning models and enabled more accurate predictions. Feature selection was important for identifying the most relevant predictors of the disease risk. The logistic regression model was chosen as the final prediction model due to its high recall score. Techniques such as mode combined with atomic links, undersampling, and min-max scaling were used to handle the imbalanced data and improve model performance. This project provides a valuable example of how machine learning techniques can be applied to real-world problems to achieve positive business impact. Overall, this project highlights the importance of careful data preparation and analysis in machine. So that is all about my project. So thank you, AlmaBetter.